All right. It's the last lab. Body comp. Position. Body comp. All right. Let's get to it.
So, a healthy person's body composition, we have lean tissue, essential fat, non-essential fat, bone, and then other organs. So for males and females, I'll let you read the differences, but lean tissue consists of muscle, skin, bones, organs, and blood. And then fat tissue, what we'll be testing today, consists of our fat.
And just want to point out, fat is not bad. We require fat in order to survive. You can't have 0% body fat and survive. You can see that the range or the target percentages, there's probably going to be a range for males and females for target fat. And let's see, between non-essential and essential fat, we've got 15% for males and about 27% for females. So we need it. It makes up our lipid bilayers and all of our cells. Any membrane has to have fat, otherwise it will not exist. So very important that we have fat. It insulates our nerves. We need fat. All right. That made my point. All right. So since we're talking about body composition, primary thing that we're looking for in this lab is body fat percentage. So we have two different types of body fat. We have subcutaneous and visceral. So subcutaneous body fat is fat located below the skin and above the muscle. That is going to be right here. So on this person's abdomen, this is their abdominal subcutaneous fat. It's popcorn looking stuff. I've now ruined popcorn for you for the rest of your life. So that's subcutaneous fat. I'll code it red for subcutaneous. Then we have visceral fat, which is all this popcorn stuff surrounding the organs. And I know the arrow points towards the intestine. It is not your intestine. It is this stuff that surrounds your intestine, visceral. So around your organs.
Visceral fat is generally the stuff that really isn't good for you. It's the brown fat that's been linked to cancer. Cool. So there's a bunch of different ways, a bunch of different methods we can use to measure your body composition. The most direct way that we can get it down to the T is through dissection. Please don't dissect each other to try and figure out each other's body composition. There are other accepted ways of doing it. All right. The next best way to do it is with dual energy X-ray absorptiometry. Now, that's called DEXA. All right. DEXA scan. It's you put them inside, you slide them in, the thing spins and boop bop beeps, and then out comes your results showing your body composition. Feel free to Google the exact science on it and how it uses dual X-ray energy to get your the density of different materials and figure out what's fat, what's lean mass. Hydrostatic weighing. We have a hydrostatic weighing tank inside our lab here at SUNY Cortland. That was the gold standard for a long time. We'll cover that a little more later. Air displacement plethysmography. Almost got it that time. That's basically the BOD pod, and what the BOD pod does is it uses the volume of air before, as in once it's calibrated, to once you're inside of it, including weight, to figure out your body fat percentage. A waist-to-hip ratio is less so a body composition tool and more so just a general health tool. It takes the circumference at your waist, the circumference at your hip, and uses it to determine your approximate health status because waist-to-hip ratio has been linked to other health factors or health problems, issues. Skin fold is what you might see often with a lot of different wrestlers when they go in. You pinch the skin, measure the subcutaneous fat, and then there's bioelectrical impedance, BIA, bioelectric impedance analysis. We're going to go through all of these individually.
All right, so hydrostatic weighing, like Seth said, has long been the gold standard of body composition measurements. And the way it works is you measure an individual on like a normal scale, so on dry land, and then you weigh them underwater. And underwater, an individual typically weighs less than 10% of their normal body weight. So we're pretty buoyant. We float. And there's several things that cause the body to float, and that includes fat, air in the lungs, and air in our GI tract. So we're measuring body fat percentage, or we're calculating body fat percentage based on the weight that our weight in the water. And we have to compensate for the air in our lungs and the air in our GI tract, and we'll talk about that in a little bit. AKA in this slide.
So for hydrostatic weighing, we have our reserve volume, body density, and we use those two numbers to get our actual body fat percentage. Reserve volume, again, the amount of air as we covered in our
ventilatory
lab, thank you, Ben, is the amount of air that we can't breathe out no matter what. Now, because our reserve volume can be directly correlated with our height, we can use our height and age to determine what our reserve volume might be. All right, and those exist in this little equation for males and females that Ben is underlining. Okay, so once we have our reserve volume, we take it and we plug it into the body density equation. Reserve volume goes right there. We use a whole bunch of other factors such as weight in the air, your body weight in the air, as I circled there. We have your weight in the water. Oh, that's not a very good color. Let me try this one. There we go. That's a little better. WW, your weight in the water. So your weight in the air minus your weight in the water over top of D water. D water, as I'm circling with the light blue. D water. That's the density of the water. Now, what that actually means is based on the temperature of the water, as you can see in the chart over here to the right, the density of the water changes based on the temperature. So when we're in our lab actually doing the hydrostatic weighing, we'll be sure to take the temperature of the water. Generally, it's around, 24 degrees or something like that. 24 degrees Celsius. We take this number, 27 degrees Celsius. We take that number and plug it into our equation down here. Okay. So again, all these different variables are around here. We can find them relatively easily. Weight in the air. We measure your weight in the water. We have the density of the water, and we calculate your reserve volume. It looks like a lot. It looks kind of overwhelming, but it's all just a bunch of variables we throw into an equation and pump out the math. Okay. Then we have our Siri equation for body fat percentage. Once we find the body density here, we plug it into our Siri equation for body fat percentage, do the math, and we get our body fat percentage for the individual that we dumped underwater.
So this method for body composition measurement is one that we didn't tape ourselves doing, but we have a nice video of someone else doing it, and we will be giving you sample data, and you'll be using that data to go through these calculations to find body fat percentage for that individual. All right, so moving on, we have air displacement plethysmography. And the most popular brand of device that uses this technique is the BodPod, and we actually have one here on campus. It's in the fitness assessment room at the Student Life Center. And we would be using this if we were here on campus, but unfortunately you're not here, so we cannot use it. So the way this works is it measures body volume and density in a space of known volume. So we have that egg-shaped looking thing on the right, and it knows the volume of space within that within the device. And by making small changes in volume, it has a diaphragm in the back that, just like I showed you in the ventilation demonstration with the diaphragm where it changes the volume inside the thoracic cavity, the diaphragm inside of the BodPod changes the volume slightly, which changes the pressure, and based on those changes of pressure, it's going to allow the BodPod to calculate body fat percent, fat-free mass, lean mass, and it's also going to, based off of those first three values, be able to tell you how many calories you need to eat or consume in order to lose weight, maintain your current body composition, or to gain weight, which is pretty cool. It's not just telling you your body fat percentage or your body composition. It's giving you more information. It's interpreting that and telling you how many calories you need to consume based on your fitness goals or your body composition goals.
More on the waist to hip ratio. So it's waist circumference divided by your hip circumference. Okay. Waist can be determined halfway between your last rib and iliac crest. If you're not familiar with where those are, just know that it's about the level of your belly button. So your waist belly button. Then your hip circumference can be determined at the level of your greater trochanter. Okay. So if you pop your hip out to the right side, and you feel for that bump in the outside of your right leg, that will be your greater trochanter. It's one of the heads of your femur. Well, not the head of your femur. It's kind of another protrusion, but that's how we determine the level of your hip, the widest point of your hip. So in total, it's going to be your waist, the level of your belly button circumference, divided by your hip circumference around your greater trochanter. Now, that doesn't measure body fat percentage or your amount of body fat, but it has been used as an estimation of one's cardiovascular risk. For example, the chart down here, I'm really enjoying the colors today, so I'm going to stick with it, shows you your cardiovascular risk in relation to waist to hip ratio norms. Okay, so if you have a 100 centimeter waist and an 85 centimeter, it'd be the inverse. 85 centimeter waist over a 100 centimeter hip, you'd be excellent if you're a male or a female. All right. So it's just a ratio. It's just a ratio.
All right. So next we have what's called bioelectrical impedance analysis. And the device being held by the person, or the hands popping out of the bottom right-hand corner of the screen, is a handheld bioelectrical impedance analysis device. It looks like a little video game controller. And the way it works is it sends a weak electrical current through your body. So let's see, we'll keep doing the colors. So current's going in one arm, going through your body, and it's going out the other arm. And we have the fat in your body resists electrical current as an insulator. So if you have more fat, it's going to resist that current more. Less fat, resist it less. And if you have more muscle, muscle contains water and electrolytes, which conducts electricity. So based on the amount of electricity or the current coming back out of this left hand right here, it's going to be able to estimate the amount of fat that you have based on a couple of different things that you enter in. So on the screen, when you set up the device, you enter in things like your gender, your age, your height, your weight, if you're an athlete or not. And it's going to take all those things into consideration, as well as the resistance that it measures, how much current is coming out on that left side. And it's going to be able to calculate your body fat percentage. Now, the measurements using this device can vary, and there's a lot of factors that cause that to vary. First, we have food and drink consumption. So if you wake up in the morning, we all know that when you wake up, like throughout the night, you've lost water, and usually an individual wakes up dehydrated. So if you take your body, or you measure your body fat percentage using this device in the morning, if you're dehydrated, you have less water, and it's going to overestimate your body fat percentage. That's because water conducts the electricity, like I said, in the muscle. You've got water and electrolytes, and if you have less water in your body, it's not going to conduct the electricity as well, and it's going to think that you have more body fat percentage. So if you do that in the morning, and then you go and you drink water all day, and at night you do the same test, it's going to think that your body composition has changed based on your hydration level. Same thing, things that you eat can alter that. Medications, maybe like a diuretic, something that causes you to get rid of fluid throughout the day, that can change your level of hydration, and that can affect your body composition based on this test. Various medical conditions, and lastly, we have menstrual cycles. So I'll talk about it in the video later, but the physiology of a woman's body in week 1 of the menstrual cycle versus week 4 of the menstrual cycle is very different. And the amount of fluid that's retained in the body during those weeks is also very different. So if you have a client and you're a personal trainer, and it's a woman, and you want to measure their body composition over time and you use this device, you want to do it, say you measure at week 1 of the menstrual cycle, you want to, the first time, you want to do every other measurement week 1 of the menstrual cycle for over time to measure their progress. You don't want to do week 1 versus week 4. That's going to change a lot in just a couple weeks, and that doesn't necessarily mean that their body composition has changed. It's just based on level of hydration.
And skin fold calipers. Again, this measures subcutaneous fat instead of visceral fat. We can use certain formulas that have been derived to convert skin fold caliper measurements into body fat percent estimations. So if we give you all data for the different thicknesses of different folds around the body, you should be able to take those numbers, plug them into the equation for the different sites, and figure out our subject's body fat percentage. Okay. Now, with that said, is the way I test, the way I pinch, becomes reliable to myself, but reliability between different testers, right? Inter-rater reliability becomes an issue because of different methods, different styles, just different testing in general. Okay. So if I go through, hi, I'm Seth, I'm going to test your entire team, day in, day out, sure, that can be a reliable test. But if we have a bunch of different testers, a different AT, athletic trainer every single time that's testing your body fat percentage, or a different coach, that might be less reliable than you might want. There might be a better way to go about that, because everybody measures it slightly different.
All right, so here we have a couple different, there's different equations that are associated with each of these groupings of sites. Sites, we mean different points on the body where we get folds of skin to measure the thickness of. The one that we use in lab, which is a good general formula, especially for people our age, is the 4-site formula. So for this, we use an abdominal fold, a suprailiac fold, a thigh fold, and a tricep fold. So the abdominal fold is going to be a vertical fold, about an inch lateral from the belly button. The suprailiac fold is going to be a diagonal fold that is parallel with the iliac crest.
I call it the love handle fold.
Yeah. Then we've got the thigh fold, which is a vertical fold in the middle of the thigh. And this one, it's important you have the person's leg relaxed. Then we have the tricep fold. So again, you want it to be relaxed, the arm, and it's going to be in the middle of the tricep. And that's a vertical fold as well.
Note that this is different than what we display inside our lab video at the end. We made a slight mistake there. We didn't include thigh, we did tricep instead. So just know that for the 4-site formula, the data that we will give you, it will be abdomen, suprailiac, thigh, and tricep. Okay, so again, this is just a diagram showing how to pinch the skin. Make sure you don't grab muscle underneath. Make sure that the calipers aren't directly over top or next to the fingers. Give it a little bit of space so that's not to skew the data. For the vertical folds, we've circled the 4 folds that we are going to be measuring: tricep, stomach, suprailiac, and thigh. And then Ben's Ben's drawing a diagram over the diagonal and vertical folds. So basically, vertical fold means you pinch such that there's a fold that runs up and down. All right. Horizontal, such as the horizon, will be flat, parallel with the floor. Vertical is perpendicular to the floor. So we're going to be taking these measurements while you're standing. And you want to make sure you take all the measurements on the same side of the body, just for accuracy. Okay. These things I've kind of already covered. Again, keep the calipers 1 centimeter from the fingers. Maintain the finger pinch while you read it, or else you'll give it a nasty pinch from the calipers. You assumptively use your index finger and your thumb to pinch and actually grab the skin. And once the caliper is squeezed, wait between 1 and 2 seconds before you actually read, allowing the calipers to settle into the tissue. Now, with that said, you don't want to hit the same pinch over 3 times in a row. You want to rotate throughout the different sites to prevent skewing your data as the tissue might adapt to being pitched. Not necessarily adapt, I should say, but it would kind of
Get back to normal thickness and texture, or usually.
yeah, that sounds about right. Again, measurements within each site should be made within 1 to 2 millimeters of each other. If you want to mark it with a pen, that's the best way to do it after you've measured where it should be taken.
All right, so we realize that you don't have a lot of the equipment that we would have in the lab. Hopefully you have something that you can use to measure waist to hip ratio. If you have a tape measure, that would be ideal. If you don't have that, you could use like a string, and maybe if you have a ruler or a yardstick or some other way of measuring the length of a string, you can wrap the string around you the same way you would use a tape measure, like the tape measures we have in the lab, and then you can measure the length of the tape measure once you've outstretched it for the waist and hip measurements. BMI, that is simply your weight in kilograms divided by your height in meters squared. And you should be able to do that at home on your own if you know an estimation of your height and your weight. And obviously you can't do hydrostatic weighing or skin fold measurements unless you have a skin fold caliper at home. But we will be showing, we'll be giving you demonstrations of these techniques in the lab video that we have following this. And we'll be giving you data based on those techniques for you to do the calculations with. So what you're turning in are those 4 things. And I know, again, you can't do bioelectrical impedance analysis, so not going to require you to do anything with that. So the 4 things that are up there right now that you see at this moment, those are what you're going to be turning in on your lab. And as always, the discussion questions. Now, I have some good news for you. This is supposed to be a lab write-up lab. We're not going to make you do a lab write-up. So up until this point, you've been doing a couple quizzes on previous labs. Might be one for this lab. I don't know. We haven't decided yet at the point.